Hi there, I'm Tim from Experimental RC, and today in this video I'm going to be talking about a very cool aerodynamic principle known as the Coanda effect. Over the next few weeks I'm going to be releasing some videos in which I do some experiments with the Coanda effect, essentially trying to build a vertical takeoff and landing aircraft that uses this effect to give it several main advantages. However, today in this video I just want to demonstrate the effect and talk about what application it has in aircraft. Now, if we look at this demonstration here, we can see the Coanda effect quite well. The Coanda effect states that a curved convex surface, such as this ball, has the tendency to be attracted to a jet of fluid, whether the fluid is air in this case or liquid, and that's what's holding this ball in place. So in the previous example, we saw a scenario where the convex surface, which was the ball, was at liberty to move, and as such it was attracted to the jet of air. However, the theory goes beyond this and suggests that a jet of air is attracted to a surface. If the surface isn't free to move, the jet of air will actually cling to it, as we can see in this demonstration here. Okay, now that we've seen what the Coanda effect actually is, let's talk about how it can be used. First and foremost, it's a key component of Bernoulli's principle of lift. It's also used in Formula 1 race cars. The exhaust gases are actually pressurized and released on the underside of the car, creating a downward pressure, having the effect of a spoiler with much less drag. It can be used in air conditioning applications. The air is released from the conditioning unit in such a way that it follows the ceiling and disperses more evenly throughout a room or building. But the particular application I'm interested in investigating is the use of the Coanda effect in what's called a Coanda craft. A Coanda craft is a type of vertical takeoff and landing aircraft with a body shaped kind of like a flying saucer. This is what I generally use when I go outside to keep the government out. But it has the right shape for demonstration purposes. So you'd basically have a body that is convex and kind of a flying saucer shape like this, and you'd mount a fan to the top. And the air from the fan would form a high-speed jet, and it would follow the surface of the body of the vertical takeoff and landing aircraft according to the principles of the Coanda effect. Now, some supporters of the Coanda craft idea actually claim that putting a body like this underneath a propeller would in fact create more lift than the propeller alone. There's a lot of controversy surrounding this aspect of the Coanda effect, a lot of quandraversy per se, and it could be because of the Coanda craft's unfortunate resemblance to a UFO, or just because nobody's had any conclusive evidence that putting something like this underneath the propeller increases the amount of lift. So that's what I'm going to be doing in my next video. Basically, from there I'll be continuing and trying to build a vertical takeoff Coanda craft. I'll see you all then.
So one would expect the air to flow out of the fan horizontally in all directions, but due to the Coanda effect, the air bends down to almost 90 degrees. The airflow is being pushed down by the air above, because the pressure of the air in between the flow and the curved surface is reduced by the suction of the airflow. Next, another example of the Coanda effect, where I used smoke to make the flow visible. Air is being accelerated down, and part of the upper surface is in touch with reduced air pressure. This action gives the object a force up, thrust, that can lift the object. Henry Coanda realized this and then designed a flying disc based on this effect in 1932.
Kinakabahan ako sa 6.